The graphs of sine and cosine functions are different than other functions. These graphs have a wave-like appearance, continuing the same pattern after a certain period.
The three key points in graphing the sine and cosine curves are the maximum, the minimum, and the intercepts. As you can see by the diagram, to graph these by hand, you need 5 points. After that, the pattern repeats.
All sine and cosine graphs follow a similar pattern. The parent functions are as followed. With those in memory, there are still factors that shift, morph, and stretch the graphs. These are the equations of the two functions. The A affects the amplitude, or the height of the graph from the midpoint. Let's say we have the equation y equals 2 sine x. We graph the sine equation like normal, start at 0, but now, instead of going up 1, we go up 2. Then we go back to 0, down 2, and finally back to 0 again.
The B affects the period, or how long it takes before the graph starts repeating. For this, you have to use the equation 2 pi over b. Take for example the function 1/2 cosine 2x. The b, or the 2, must be put into the equation to find the period, which in this case is simply pi. So instead of going to 2 pi, like the parent graph, we only go to pi. The graph still has to have 5 points, so we split the period into 5 parts: 0, pi over 4, pi over 2, 3 pi over 4, and pi. The a, or the half part again, affects the amplitude. So in this case, for cosine, instead of initially going up 1, we go up 1/2. Then we go down to 0, then down 1/2.
The D and the C affect the horizontal and vertical shifts respectively. Take for example the function y equals sine x plus 3. Note that the function can be written as y equals 3 plus sine x as well. The 3 shifts the entire graph up 3. If it were a negative 3, it would have moved it down 3. Draw a line across 3 to help you see where your eye should be. Now that the line is there, imagine you are graphing like normal. Plot a point at the 0, then up 1, back to 0, down 1, then back to 0 again.
For the horizontal shift, take the example y equals cos x minus pi. Because the c in the equation is a negative, the c, or the negative pi in the equation, turns into pi. So, as a horizontal shift, the entire function moves right pi spaces. To put it all together, pause the video and graph the function y equals negative 2 sine pi x minus 1/2 plus 3. Did you get something like this? To do this, you must first shift the entire graph up 3 and draw your line to see where your eye should be. Now you have some choices. You can either find the period or find the horizontal shift. The period in this case is 2 because 2 pi over pi is 2. The horizontal shift is 1/2 because of the negative 1/2 in the equation. It moves over to the right 1/2 spaces. Now the negative 2 in the front changes the amplitude. A normal sine function starts at 0, then goes up 1, but in this case it starts at 0, then goes down 2 because of the negative. Then it goes up back to 0, up 2, then down 0. Then there you have it.